Hello everyone. So today we are solving a question of JEE 2017. So this is on the topic of waves right here. Yeah. So let's first read the question. As it says, they're given a block of mass m which hangs vertically at the bottom end of a uniform rope of constant mass per unit length. The top end of the rope is attached to a fixed rigid support O. Okay, so there is a transfer wave of wavelength lambda naught is produced at point O on the top, and the pulse take times TOA to reach the point. If the wave pulse of the wavelength lambda naught is produced at point A without disturbing the position M, it takes time A naught to A to reach point O. Which of the following options are correct? Okay, so here what are the things that we have to discuss here? What is the time taken from going to A to O or O to A? The velocities of the two pulses at the midpoint, the wavelength of the pulse one, okay, whether it becomes longer or shorter, and the velocity of any pulse along the rope is independent of frequency of phase. So we have to tell this much things here. So we erase all this and let's write all the formulas that we know. We know that for a transverse wave in a rope, the speed or the velocity that can be it is technically equal to root under T by mu, where T is the tension at that point and mu is the mass per unit length of that rope at the time. Okay, so here we cannot find any of the term like lambda or frequency or something like that. So velocity is only dependent on the material property of the rope and the tension in it. So we can mark our option, I think, yeah, D. So it is independent of its frequency and wavelength. So option D is absolutely correct here, as we have not found any term of lambda and f here. So moving further, so what will be the time taken by the time AO or time OA? Okay, so let's say at any point, suppose this is the point, okay, at some distance R here, what will be the tension at that point? It will be nothing but the due to the weight of this rest of the rope and this M. So at that point R, what will be the tension at that point? It will be, let's suppose that the total length of the rope is L. Okay, so what is the rest mass or the mass which is left after covering the length R? It will be nothing but L minus R. If you multiply this with mu, that is mass per unit length, plus M times G, this is nothing but the tension. M should not be multiplied with the whole mg. Sorry, we can do it. Okay, so this is the net tension at that point. Okay, so if we can see whether the pulse is coming from this point or this point, at a point, single point, the velocity of the wave is same, and since they are covering the same path, ultimately, like, there's the direction matters. It is coming from the same path and going through the same path. So we can simply say the time AO is equal to OA, because they are covering the same path with same velocity at single point. Okay, not at different point. Obviously, there is a difference in the velocities, but ultimately they are covering the same path with same velocity. So we can mark our option A as correct here. Now, moving further, what we need to do here is the velocities of the 2 points are the same at the midpoint. So see, I have already cleared your doubt, and you might be thinking that our option B is also correct. You will find most of the places that the option B is correct, but JEE Advanced has not given this as your option, because I'll show you how. Let's suppose this point. What will be the speed or the speed of wave that can be possible at this point? It will be nothing but some root T by what will be its total mass is mu into L by 2 plus M times G. Sorry, what is the tension here? Tension will be mu times L by 2 plus mg. Okay, root under and divide by the mu. You will be thinking this is the possible speed at that point, but if you notice that I am talking about speed here, because the speed of air can be same also, but you cannot equate the velocity, because velocity is a term which includes the direction also. For this pulse, the velocity will be in this direction, and for this pulse, the velocity will be in this direction. That's why JEE Advanced has not given this as there in the final answer, because they are talking about the velocities here. That's why this option is correct. If they would talk about speed and all, so at the same point for the both pulse, the speed will be same here. And now they're given the wavelength of the pulse one becomes longer when it reaches a point A. So at point A, what do you think? The tension is maximum or minimum? So at point, the tension will be minimum, because they have covered a complete rope and only this part is left here. So if the tension is less, okay, so if tension decreases, So we can see speed will decrease. And what is speed? Let me write this by lambda, because hc by lambda is equal to f. So we know that like c by lambda is equal to f. If speed is decreasing, and we know that the like frequency once released, it is same, obviously frequency is always need to be constant here. So if c decreases, lambda should also be decreased here, and here written the wavelength becomes longer when it reaches point A. So it means this option is incorrect, because at that point speed is decreasing, and if the frequency is constant, the wavelength must should be decreased here. Hence we got our final options as A and D here. Thank you everyone.